Good morning all of you. I am Tanushri from Civil Engineering branch and today I am going to teach you the Theory 2 paper which name is Structural Design 2. So in the last class we discussed about the design considerations of masonry walls. So today we will continue from this. So the first consideration is depending upon permissible stresses. So the first permissible stresses is permissible compressive stress. So the permissible compressive stress is a modified value of basic compressive stress since the latter is influenced by slenderness ratio of the wall, eccentricity of the loading, area of the cross section of wall, shape of the masonry units and types of loading. The loading may be uniform or concentrated. The basic permissible compressive stress of masonry under normal conditions is a function of strengths of its constituents, bricks and cement sand mortars. The permissible compressive stress value may be increased under certain eccentric loading conditions and in case of concentrated loading as given below in table. So this is the table in which increase in permissible compressive stress is here. So the first condition for the eccentricity of loads and the second condition is concentrated loads. So for eccentricity load, there are two conditions according to which percentage increase of permissible compressive stress. So if the eccentricity is greater than 1 by 24 and less than equal to 1 by 6, then the increase of permissible compressive stress is increased by 25%. Then second condition is if eccentricity is greater than 1 by 6 only, then the percentage of increase is 25%. So this is for your eccentricity loading. Then coming to concentrated loading system. So here 4 types of conditions. So first condition is the bearing on central strip not wider than half of the thickness of the wall, then the increment of permissible compressive stress is increased by 50%. Then the second condition is if the bearing on full thickness of the wall, then it is increased by 25%. Then bearing on central strip of wall wider than the half of the thickness but less than the thickness of the wall, then it is increased by interpolation between I and 2I. That means the value should be in between increased by 50% to 25%. Then for the fourth condition, concentrated loads from lintel over an opening, then it is increased by 50%. So these are the permissible compressive stress increment according to the condition of eccentricity loading and concentrated loading. And now comes to another stress property, that permissible tensile stress. So according to the permissible tensile stress, generally it is assumed for design purpose that masonry is incapable of taking any tensile stress. However, in case of lateral loads normal to the plane of wall which causes flexural tensile stress in panel, curtain partition or freestanding walls, flexural tensile stress may be permitted as in table given below. So here for the tensile stress we divide the grade of the motor into two types. So first grade is your grade M1 or better motor, and second one is your grade 2. So here direction of bending and direction of tensile stress on bed joint, and according to this what are the permissible tensile stresses are given in megapascal here. So for grade M1, for bending in vertical direction where tension developed in normal to bed joint, for this condition the permissible tensile stress is taken as 0.07 megapascal. And for the same grade, that is M1, for bending in the longitudinal direction where tension developed in parallel to the bed joint provided crushing strength of masonry unit is not less than 10 megapascal, then we will take the permissible tensile stress 0.14 megapascal. Then coming to the grade M2, for bending in vertical direction where tension developed in normal to the bed joint, for this case the permissible tensile stress is 0.05 megapascal. Then for the second condition, which says that for bending in the longitudinal direction where tension developed in parallel to bed joint, provided crushing strength of masonry units is not less than 7.5 megapascal, here the permissible tensile stress is taken as 0.10 megapascal. Then comes to another stress material, that is permissible shear stress. So first one is your permissible compressive stress, second condition is your permissible tensile stress, then third one is your permissible shear stress. So in case of masonry walls built of M1 motor or of higher grade and resisting horizontal forces in the plane of the wall, the permissible shear stress calculated on the area of the bed joint shall not be exceed the value obtained by the formula given below to a maximum of 0.5 megapascal, and the formula is represented as Fs is equal to 0.1 plus Fd by 6, where Fs is equal to permissible shear stress in megapascal and Fd is equal to compressive stress due to the dead loads in megapascal. So this is all about the stresses consideration in wall. So now comes to the next part, that is slenderness ratio. So we all know about the slenderness ratio. So the slenderness ratio is the ratio of effective height or length of the wall to the effective width. So both the values, one with respect to effective height and another with respect to length of the slenderness ratio, shall be calculated, and the lesser of the two will be taken as for the design purpose. For load-bearing walls, this ratio shall not be exceed 27. Then next part is your effective height for the wall section. So effective height for the wall supporting RCC floor or roof and that of freestanding wall are as shown in the figure. So this one is another wall and this one is another wall. So here the first figure is represented effective height of wall supporting reinforced concrete floor or roof respective of direction of span, and this wall is a freestanding wall. Okay. So now comes to next factor, that is effective length. So effective length is denoted as small l, as these are wall shall be defined as diagrammatically represented in figure 1. When slenderness ratio is based on its effective length, a cross-section wall, that is piers or buttress, shall be deemed to provide effective lateral support if it has the minimum dimension as shown in the figure 2. So these are the effective length of the wall according to various purposes. So now comes to the next part, that is effective thickness. So effective thickness is denoted as small t, and this effective thickness of the solid wall shall be actual thickness of a wall in case of solid wall bounded into piers or buttress. Effective thickness for determining slenderness ratio based on effective height only shall be actual thickness multiplied by stiffening coefficient as shown in the table below. For solid walls stiffened by cross walls, the cross walls shall be assumed to be equivalent to piers of the width equal to the thickness of the cross-section wall, and of thickness equal to 3 times of the thickness of stiffened wall for determining stiffening coefficient from below table. So these are the value of stiffness coefficients for walls stiffened by piers, buttress or cross wall. So here you can see according to the ratio of SP to WP, where SP is the center to center spacing of the piers or cross wall and WP is the width of the pier in the direction of the wall or the actual thickness of the cross wall. So according to this, we will take the stiffening coefficient. So for the first condition, that is TP by TW, if 1, then we will take, for the value of ratio 6, we will take 1. For 8, we will take again 1, and up to 20, we will take only 1. Then if the TP by W is equal to 2, then we will take for 6, 8, 10, 15 and 20, 1.4, 1.3, 1.2, 1.1 and 1.0. Similarly, for the third condition, that is TP by TW is equal to 3 or more, then we will take the thickness coefficient as for 6, 8, 10, 15 and 20 or more, 1.2, 1.7, 1.4, 1.2 and 1.0, where TP is the thickness of the pier and TW is actual thickness of the wall. So in this way, the stiffness coefficient we can provide. So now comes to the design consideration of masonry for columns. So first of all, according to the masonry column, the column are different types. So there are 3 types of masonry columns we are using in the construction work. So first column is normal column, then second one is piers or abutment, which we will provide in case of bridges. Then third one is buttress. So these all 3 are one kind of columns, that is compressive members. So first of all, column. A column is an isolated vertical member having width to thickness ratio not exceed 4. Similarly, piers and abutments. So a pier is a thickened portion of the continuous wall provided at certain interval to the increased stiffness of the wall or to carry concentrated loads. Piers and abutments are substructures in bridges and culverts. Brick or stone masonry piers and abutments of solid mesh are constructed mainly for load span or superstructure. Then buttress. So a buttress is a pier projecting from either or both surface of a wall, decreasing in cross-sectional area from the base to top. So today this much.